Okay, so now we're going to actually write out and do some math over the posterior distribution. So probability of mu given your data is equal to, now I'm going to write the likelihood first. So mu to the mu to the n1, number of ones that you observe, 1 minus mu to the n0. And then we'll write the beta distribution for the prior. So this is just mu to the alpha minus 1. Remember, it's this thing right here. Mu to the alpha minus 1, 1 minus mu to the beta minus 1. And remember to divide that by this beta function. That's still part of our prior. And then we have to divide by the marginal likelihood, this guy right here. So we'll write this out. 0 to 1, mu to the n minus 1, 1 minus mu to the, I'm sorry, I meant to say n1, and then 1 minus mu to the n0, mu to the alpha minus 1, 1 minus mu to the beta minus 1. And remember, we also have to divide by our beta function. Now, you'll notice right away that these cancel out, which is nice. So let's keep going. And let's simplify a little bit. So we get in the numerator mu to the n1 plus alpha minus 1, 1 minus mu to the n0 plus beta minus 1. So just combining those two exponent terms, dividing by this integral, and we'll even combine again in the integral. So n1 plus alpha minus 1, 1 minus mu to the n0 plus beta minus 1 d mu. And let's simplify even further. Well, the numerator doesn't change. But this here has the same form, if you look closely, as that. So what we just realized is that this denominator is actually a beta function. It's actually a beta function where the alpha parameter is just n1 plus alpha, and the beta parameter is actually n0 plus beta. Okay, so now this is our posterior distribution. So let's bring it back over here. And let's notice that this posterior distribution is actually just the same form as our beta prior. This is a beta PDF, except now, so you notice it's mu to the something, 1 minus mu to the something over the beta function. And that's exactly what we have here, except that something is different. We find out that the alpha term has become n1 plus alpha, and the beta term has become n0 plus beta. So let me just make it clear by writing that the posterior is equal to or distributed as a beta with these new parameters. So what does this mean? Well, it means that basically remember that alpha, this first parameter, is the pseudo number of ones, and the second parameter is the pseudo number of zeros. And so you've noticed that in our update step, we've just taken the number of ones that we observed, and we've added it to our alpha parameter, and the number of zeros that we observed, and we've added it to our beta parameter. And the posterior distribution is also a beta, and that's really nice. That works out really well, and it makes intuitive sense. And so in the next video, we'll talk about how to take the maximum of this posterior distribution.